We'll go for one case study, value study or value methodology approach in a seat assembly in passenger car vehicle. So as you know, we have different phases. We start with a pre-workshop phase, that is nothing but orientation phase. Then we have 6 workshop phases. Then we have 2 post-workshop phases. So here the objective of the orientation phase is to make the people aware from different departments that they are going to form a team and then they are going to take the projects. Here they have taken the seat assembly as the project involving all the cross-functional team. The first phase is nothing but the information phase, where they get taken the information about the components, what they're going to take it for the project or for the value improvement. They've taken the frame assembly, cushion assembly, and chain, which is a part of the heat seat assembly. And they also taken the consideration of how much is the thickness of the individual parts, frame, cushion, and chain, and what is the overall weight. What is the material being used? For frame, they are using cold rolled sheet. For a cushion, they are using polyurethane polyethylene. And they also consider the cost. How much is the cost? And is the overall volume that they will consider, or the annual quantity. So this is normally how the seat assembly looks without this polyurethane or polyethylene. This is the complete seat assembly. This is nothing but a hat section they call. And in information phase, you also need to note down all the bill of material, and you also need to get the drawings and etc. And you should also know how much is the quantity, and you also need to know whether the drawing is available or not, because in information phase you need to collect all the micro level information, and you also need to get all the details with respect to the technical point of view and even the cost point of view also. Technical plus financial aspects, micro level details are very much important during the information phase. And here they have analyzed the cost, which is nothing but the present product cost information. So they will consider different aspects with respect to the frame material and the labor cost, and then the plywood and the upholds the material, and how much is the overall cost, like, for which involves all the things. Even
volume is very low, sir. If you can increase your volume.
I consider the maximum volume. 1 second, is there any other? Hello? 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 Hello?
It's audible for us.
Yeah, carry on, sir. Carry on.
Here it is showing 100%. 1 second. Just see, is there any other possible? So always you can also have 100% in your system, so that it will be good, I feel.
Yeah, carry on, sir. Carry on.
Yeah.
Carry on.
Yeah. So here they will consider the overall cost of the seat assembly is 2,253.47. So they will analyze the detailed each and every aspects, and they found out this is the overall cost. Sir, I'm getting the echo. Is it possible to mute? Yeah. So next phase is nothing but a function phase, where we go for a function analysis. So as I said, we have 3 components of a seat assembly in a passenger car, which is nothing but the frame assembly, cushion assembly, and also the section. Now here what I'm going to do is that I'm going to analyze the function, which is nothing but a random function analysis, which is the first step. And also I'm going to organize the function by categorizing that into basic function, secondary function, etc. So here the random function or the various functions of a frame assembly is that it should have proper shape or it should obtain shape, it should support weight. As you know, the basic function of the seat itself is to support weight because the occupants will be sitting in the seat. So the basic function or the function is nothing but the relevant function which is required for the particular product is nothing but the support weight. And the other functions include ensure dimension, which it's also resist corrosion. It should join the components. It should identify the manufacturer or the brand of the particular company. It should identify the specification. It should also uh, even this accommodate document is also a part of this. And again, next one is nothing but the cushion assemble, where it also includes the similar type of functions as that of frame assembly. So as you know that we have the rexine that which is required for improving the aesthetics and also improving the appearance. So here the overall function of assembly is again just they done the micro level analysis where they found these are the contributing functions which are required for the functions of the complete assembly. Like they should obtain shape, they should support weight, they should ensure dimension. It also ensure the occupant accommodation. It should join the components. It should resist corrosion, and also it should assure comfort. That is, it's also good that if you still narrow down the overall functions, whatever you have organized or classified into, still you can also narrow down, and you can take it this further for your fast diagram, or you can also take this complete one into the fast diagram, where you can also find out if in case any unwanted functions are there, then you can neglect straight away. So here the basic
I have a question, sir.
yes sir.
Previous slide, this slide, this last Rexin, improve aesthetics and improve appearance.
Okay.
These two variables are attribute variables, aesthetics and appearance.
Exactly.
So how to manage this?
Because like even for that particular aesthetics or particular appearance, we are going to pay money. The customer is going to pay money, and even the company is going to spend money for that. So it's like that is all time function. Like the aesthetics, what we call it should come under the all time function, and the comfort is also should be all time function. So
no, you as you said that it should be a measurable variable.
exactly.
And aesthetics, how it can be measured?
Yeah, it is that's why this is coming under non-measurable. Sir, is it possible to mute? Yeah. So here it comes under non-measurable noun, but and again, even this needs to be taken. Even whatever the book I have given you in the PDF format, they have considered this even though this comes under non-measurable noun, and this are being taken as all-time function because this is required. And again, the company is spending money or resource for improving the aesthetics or improving the appearance, and even these are being considered in the fast diagram in the column in the category called all-time function. And it's like sometimes it is highly difficult to categorize or difficult to analyze since it's coming under it's coming under non-measurable noun. It's very difficult sometimes to provide the resource allocation for this particular function, but still if we involve some expertise, then we can look into it. So here the basic function, as I said, the basic function of a seat is to support weight. So here I'm going for a higher order function. How I can support or why to support weight? I'm asking the question why I need to support weight to accommodate the occupant. So here the higher order function is to accommodate occupant. I'm not going to spend any money for this, but I'm going to spend money for the basic function. Or the customer is going to pay money only for the basic function. So how to support weight by obtaining a shape, or how to obtain the shape by ensuring the dimensions, and how I'm going to ensure the dimension by joining the components, how I'm going to join the components by collecting the material. So here the lower order function is but collecting the material for which the customer is not going to pay any money, or the company is not going to spend money for this particular thing, because this is out of scope. So uh, as I said, left scope line to the right scope line where our project scope lies. We also need to describe the project objective, and also the all time function, even one time functions should also be here. So this company had approached the function cost worth analysis approach rather than going for the function cost worksheet where they allocate the percentage of resource or percentage of cost for the individual functions and going for a Pareto analysis. So like given a last yesterday example, same examples here where they analyze the function cost worth analysis, function cost versus function worth, and also they identify the value index. If the value index is much more higher, then they also look for some alternatives. So here they have found that the material optimization as one of the basis, and also reducing the welding area is also they found. And SFT, it's nothing but the percentage of the coating that also they found. These are some of the alternatives they have found. And since the cost and worth are almost same, there is no possibility. And again, this is the data that which is coming from the cost functional team. So they have found there is no scope for. It is, I can say, it's sometimes very difficult to give one value, but still, they if I give a one value, then I can look at two possibilities. One possibility is that there is no possibility for any further value improvement, or I can say that the worth and the cost are almost same. And again, it's worth is again a dynamic one, which always very difficult to predict by the company, but it's depending on the dynamic factor which is been perceived or given by the customer. So here, for the whatever they have analyzed the higher value index for the particular functions and then particular component, they have analyzed how much is the value gap. So 220 is the highest value gap, and that goes for the supporting weight. And the source is function cost worth analysis. What they have further derived is that they have gone for a brainstorming session only for these things, for the particular weight, how they can reduce the weight, or how they can support the weight by various means. So they have generated some ideas by reducing the thickness in the head section, and also they found that other three ideas which include decent change in the mounting bracket, also thereby reducing the weight. At the same time, they also found some decent change by reducing the weight in the seat mounting bracket itself. It's in the hinge mounting bracket, this in the seat mounting bracket. And the last idea is that to change the source from X to Y. And not only the ideas, they also taken some steps, like how they can change the sourcing of the supplier by identifying the new suppliers. And the result is that they also identify the suppliers. And again, if we are doing any design change, you also need to do some CAE and validation, which needs to be done. It's not only the validation physically, but also you need to do some testing or validation in software. There are some lot of softwares available which will validate the failure for a particular design change. And if that software proves to be correct, then they can go for a physical validation, because physical validation cost will be too higher, and again the resource will be too higher. So it is good to go the complete the validation using the computer or simulation, then we can go for the required physical test. So it's something like the each and every project or the case study will vary and approach may be slightly changed, but you need to follow the methodology. That is the main criteria. So here I'm, as I said yesterday, we need to give the ranking for the ideas in the range of 1 to 10. So here for the 4 rankings, whatever they given. So they given rankings from the cost function team, and they ranked as 1, 2, 3, 4, etc. So these are the 4 rankings. So, and then now you have to evaluate. So this is nothing but the ideas which came from the creativity phase, and it's good to go for a ranking in the evaluation phase rather than giving the ranking in the creativity phase. So we have separate evaluation phase where we need to evaluate all the ideas, then you have to give the ranking. Here, what I analyze is that 5 criteria like yesterday we have seen. The first criteria is the structural durability. The second criteria is manufacturability, the weight, aesthetics, and then the comfort. So again, this criteria can also be lesser, can also be higher, but I can consider some other criteria also. So here, yesterday I given the points starting from 1 to 10, where 10 is the highest one. So here they consider the least value 1, 2, 3, where 1 is the minor difference, and 2 is the medium difference, and 3 is the major difference. I always suggest to go for a evaluation or a third comparison like yesterday, whatever I given, because that will give more higher value, and that will be easy to take it for the decision. So here what I've done is that I'm going to compare the A criteria with all the remaining criteria and B criteria with other criteria. So when I'm comparing A with B, or when I'm comparing the structure durability with manufacturability, I have I have given major difference is there for A. So A is more important. So they given A as 3 points, and when they compare A with C, they found the difference is very small. So they given 2. And so again, you have to add vertically, horizontally, like it comes 9 points. Similarly, it comes to B is having 2 value here, so it comes 2, and C is having a 5, and E is having 2, and D is also 2. So you have 2 here. So you have to put the 2 here. This this even if you're considering the value lesser, then there is a possibility that some you cannot get accurate results. So higher the value, you can get much more better results. So again, you have to follow the same principles like whatever I told yesterday. Uh, 9. So whatever the value you got in the previous comparison, you have to put it in a horizontal manner, and you have to put the ideas. So you have 4 ideas, and again, so here they consider the 1 to 5 rankings or ratings. So yesterday I given again 1 to 10. So again, you have to multiply based on this value you are going to get with the help of the cost function team. So you have to go multiply it, and individually you will get the values, and this is the overall score based on which you can select the top 3 or 4 ideas. So I'm going to get ideas which is best based on the rankings. So they have found 2 alternatives, 81 and 76 as the best alternative, and the alternate one, you're going to get 224 rupees savings. So as I said initially, the cost of the existing product is 2,253. Whereas if they go with the idea number 1, they're going to get 224 rupees saving. And if they're going to go with the alternate number 2, they're going to get 56 rupees savings. These are the analysis they have done in the evaluation phase itself. And they also consider the other aspects with respect to the assembly lead time, and also the how much will be the number of components. There is no change in the number of components, and there is also some reduction in weight. We are going with alternate proposals 1 and proposal number 2. There is going to be some weight, and based on that, the cost is also going to get affected or gets reduced. So the overall weight for the existing product is 18.95 kg, and now with the help of the value improvement, you are going to get lesser weight. So the cost descriptions they also made after the value engineering or value analysis. So they are going to get their cost of the seat is to 2,028 rupees. So the net saving is 224 rupees for one vehicle, and they're going to get almost 6 crores 72 lakhs, 7 lakhs, 7 lakhs 20,000. So, oh no, sorry, it's 67, so 67 lakhs 20,000. So this much is the annual savings that they are going to get. So final proposals they are presented to the cross-functional team, to the top management for approval, consisting of different team or different department, and they would carry out all the analysis in the development phase. And again, this is the thing they've shown where they can able to get this much savings, and return on investment is 85 days. And they implemented it, and they also done the follow up and